On page 345, they have the basic shape of both exponentials. I would like you to draw with your red pen a dotted line on both of these, labeling the horizontal asymptote. And I just added some more graphs. Just for practice, you can draw them on 5.2, page 345, off to the side. Some actual examples. There's an example of 3 to the x. I labeled 3 points. You only need to label 2 points, 0, 1, and 1, 3. But if you want to label more, that's perfectly fine. And we find out if the base is bigger than 1, your graph is going to be increasing. If your base is a fraction between 0 and 1, then it's going to be decreasing. And what this is going to do is these are going to be our parent graphs. We get to go back to our transformations unit and practice all of our stretches, compressions, translations for these graphs as well. So our starting point, we go to example 1, graph 1/3 the x. To graph any parent function of an exponential, you will always have 0, 1. And in this case, because the base is 1/3, we will have 1, 1/3. Those will be your 2 key points. Exponential graphs will always have an asymptote. The parent graph will always have an asymptote at y = 0. So then we just have to connect the points and go towards the asymptote. This is the graph of 1/3 x. To determine each of these things, what happens to y each time our x increases by 1? What do? The y value gets multiplied by 1/3. Is this graph increasing or decreasing? It's going down from left to right, so it is decreasing. Oh, yes. Thank you. As far as intercepts go, you have a y-intercept at 0, 1. And because of the asymptote, there are no x-intercepts. Question 4 worked out perfectly. I labeled the asymptote right beside the question. The equation of the asymptote is y = 0. Domain. Every single x value is allowed. It goes forever to the right and forever to the left. The range, the y values have to be bigger than 0. You could write it this way, or you could write it this way with open brackets. Because of the asymptote, you can't have an equal sign there. It's just bigger than 0. So if you want to circle questions 3, 5, and 7, they are your basic graphs of exponentials. And what we do now is we take these basic graphs and add all of our transformations unit. So we get to review our transformations unit.